Okay, in this video, I'll be looking at exercise 19 from your lecture notes, module 3. All right, so we'll start with with this differential equation, x squared minus 1y double prime plus xy prime minus y equal to 0. Here, clearly x equal to 0 is an ordinary point, so I could easily use this as my initial guess. I find the first derivative. I find the second derivative. These are pretty standard operations at this point. Then I will multiply my second derivative with x squared, which gives me that one, and then minus 1 times y double prime, which gives me that one, plus x y prime, which I multiply x to y prime, that gives me that one, and then minus y itself, which is that one. Now, the first move here is to see the powers of x for each starting indices. So for the first one, if I put 2 in the place of n for the power of x, it'll be x squared. Second one, if I put 2 for n in the power of x, it'll be x to the 0. Here it'll be x to the 1. Here it'll be x to the 0. All right, well, that means we keep this one. We take 2 terms out of this one. We take 1 term out of this one. And we take 2 terms out of this one. Because remember, they all have to start with the same power of x, and you always want to match the highest power. So we'll write the first one as is. Minus, and here I'm going to take out 2 terms. So the first n equals 2, so it'll be 2 times 2 minus 1 is 1. A 2x to the power of 0, and then I take one more out, so minus n times n minus 1. This time n is 3. Sorry, I should write that as constant. So sorry, I'm taking out 3, so it'll be 3 times 3 minus 1, a 3x to the power of 3 minus 2, which is 1. Minus, then I'll write the rest of it. So I took out n is equal to 2, I took out n is equal to 3, now I go to n is equal to 4 to infinity, and I write it as is, n minus 2. And then for the next one, for this one, I'll take out 1 term, so it'll be plus, when n is equal to 1, so I get a1x to the 1, plus the rest, which n is equal to 2, n a n x to the n. And then the last one, I have to take out 2 terms, so minus a naught x to the 0, minus a1x to the 1, minus a n x to the n, as n goes from, I took 0, I took 1, so it goes from 2 to infinity, equal to 0. So now I need to take all the non-power series terms, so I take that one, that one, that one, that one, and that one. I'm going to write that in yellow. So that'll give me, start with the minus 2a2x to the 0, minus 3 times 2a3x to the 1. So that's gone, then it's that one, so plus a1x to the 1, that one's gone, minus a naught x to the 0, minus a1x to the 1. So that's all the non-power series terms. And then I'll write the power series terms, but for now, let me just clean that up a tad bit. So that'll be, don't forget, you need to still take that, take that, take that, and take that, and write them all together instead of equal to 0 as well. So that has to be 0. Okay, and so let's clean that up. So you get minus 2a2x to the 0, minus 6a3x. a1x and minus a1x go away, minus a naught x to the 0 equals 0, has to equal 0. So here I could combine the powers of x with their coefficients, so I have negative 2a2 minus a naught x to the power of 0 minus 6a3x equal to 0. So from here, I could see that minus 2a2 minus a naught is equal to 0. That's minus 2a2 is equal to a naught, so a2 is equal to minus 1/2 a naught. And from here, if I say negative 6a3 is equal to 0, because that's the coefficient of x, and the only way it could be 0 is for the coefficient to be 0. So that just means that A3 is equal to 0. Alright, so I have my A2, which is equal to minus 1/2 A naught, and then I have A3, which is 0. Alright, so now I write the power series terms. So I'll have the summation of n times n minus 1 an x to the n as n goes from 2 to infinity, and then minus the other power series n times n minus 1 an x to the n minus 2 as n goes from 4 to infinity, plus n an x to the n as n goes from 2 to infinity, minus an x to the n as n goes from 2 to infinity, and that has to equal to 0. Okay, so now remember, in order for me to combine these power series, they all have to have the same starting index and the same power. Well, you notice the first one, this one, and this one, they all have the same index and same power. So I'm hoping that if I could just go to the second one and take that and increase it by 2 units, okay, it matches the powers, and then that means I have to decrease this by 2 units. That will bring it to 2. Well, yeah, that works. So all I have to do is decrease 4 by 2 and increase the argument by 2, and we're good. So I'll write it again, n minus 1 an x to the n from 2 to infinity, minus n equals 2 to infinity. So I lower the index by 2, I increase the argument by 2. So n plus 2, n plus 1, an plus 2 x to the power of n plus, and I'll just rewrite the rest of it. Equal to 0. So, okay, so now all my indices are the same, all my powers are the same, so thank God. So now I could combine the whole thing into one power series. So I have n is equal to 2 to infinity of n times n minus 1 an minus n plus 2 times n plus 1 an plus 2 plus n minus an, and all that is x to the power of n equal to 0. Now, again, the only way this could be 0 is for all that to be equal to 0. So I need to try to find out for different values of n, set that equal to 0, and for different values of n, try to find out all the constants I need so I can have the solution to my differential equation. So I already have 2 of them solved for here. So don't forget, so you have that 2 pieces of information, and then the rest you're going to get from here. So I will have to solve this for the highest in subscript for n, for a. So if I have minus n plus 2, n plus 1, an plus 2 equals 2, and I move all the other ones to the other side. So since that's all that is equal to 0, or has to be equal to 0, so I have minus n plus a naught minus n times n minus 1 an. Sorry, that's not a naught, that's an. That's right. NA in my I just have to write that as, that looks like a nod. There you go. So now I just divide everything by the coefficient of an minus 2, and I can clean up the right side as well. So my an plus 2 will be, so if I write a fraction line here, so I have minus n plus 1 minus n times n minus 1. Right, and then multiplied by an, and all that is divided by n plus 2, n plus 1 with a minus. So an plus 2 will be, if I clean this up, here on the side I have minus n plus 1 minus n squared plus n. Minus n and plus n go away. So you end up with 1 minus n squared. So here you have 1 minus n, 1 plus n times an over minus n plus 2 n plus 1. Now I can clean that up even further, so that'll be an plus 2 is equal to, well, these two go away. And the other one is 1 minus n over minus n plus 2, so you get n minus 1 over n plus 2 an. Do you see that? Yeah, because 1 minus n could be, if you factor out a minus, could be written as n minus 1, right? So then the minus would cancel out with the minus at the bottom, and that's what you would end up with. So here's your recursive relation there. And I'm going to use this equation to find the rest of my constants. Now, don't forget, I'm going to actually, you know what, I'm going to take these, I'm going to take these two, cut it. I'm going to take these two right here. And I'm going to say copy. And I'm going to paste them here because I need to use them to, there you go, to be able to find all the other constants. So, all right, so here are my constants. Let me just move this up a bit. Okay, so now I have this, and remember, what is it we need to do? Because people lose sight of that when they get to this point. We need to find our solution. Now, what is our solution? Our solution is a naught plus a1x plus a2x squared plus a3x cubed plus a4x to the fourth plus a5th x to the fifth plus a6th x to the sixth, and so on. Now, in order for me to find the solution, what is it I need to have? I need to have a naught, I need to have a1, I need to have a2, I need to have a3. So I need to have all my constants so that I can have my solutions. And the way I'm going to find these constants is to use equation 1, equation 2, and equation 3. I'm going to have to use these three facts or relationships so I could find all the constants. Okay, so let's see. I already know what a2 is. It's 1 minus 1 half a naught. I know what a3 is. It's 0. So if n is equal to 2, I'll have a4 equals 2 minus 1 over 2 plus 2 a2. Okay, 2 minus 1 is 1, 2 plus 2 is 4, a2 is minus 1 half a naught, so I'll get equals to minus 1/8 a naught. Okay, I'll let you look at that. Okay, so my a4 is minus 1/8 a naught, my a3 is 0, and my a2 is minus 1 half a naught. Okay, so now let's see the next one. N is equal to 3, so that'll give me a5, and remember I'm taking this value and I'm going to here. That's where I'm going. Okay, in case you didn't see that. So continuing, so a5 will be, that means I have to take 3 and put it in the place of n, to be 3 minus 1 over 3 plus 2 a3. And that's just, so 3 minus 1, we can write it anyways. 3 minus 1 is 2 over 5, then a3 is 0 times 0, so that gives me 0. So if n is equal to 4, I get a6 equals, well, you see, if you see the pattern, you don't have to keep going to the top equation trying to see what you're going to get. Just look at a pattern. You start with 2 minus 1, then 3 minus 1, so obviously this will be what, 4 minus 1, yeah. And then here you have 2 plus 2, 3 plus 2, so this would be 4 plus 2. And here you go from a2 to a3, so obviously this will be a4. So it's kind of easy to see the pattern once you get into the groove of it. So this becomes what, 3 over 6 a4, but what is a4? a4 is minus 1/8 a naught. Okay, all right, so 3 and 6 reduce to a 2, so you get minus 1 over 16 a naught. Okay, so let's see what we can do with these. So it looks like everything is in terms of a naught, and I don't see a1, so obviously that must be my other constant. So let me just take this up so I could write what everything is here. So my solution will be, and I'm going to just write it in general first, a1x plus a2x squared plus a3x to the fourth plus a4x to the fifth plus a5x. Sorry, a naught, a1x, a2x squared, sorry. Let's slow down a little bit. And x3x cubed, a4x to the 4, a5x to the 5, a6x to the 6, so on. So now I have, so my y is equal to a naught just a naught, a1 is just a1. Now what's a2? a2 is minus 1/2 a naught, so it'll be minus 1/2 a naught x squared. That's a2. Now we're on a3, so a3 is 0, so plus 0 x to the third. Now we're on a4 plus, what's a4? a4 is minus 1/8 a naught, so it'll be x to the fourth. Okay, now we're on a fifth, so a fifth is 0, so plus 0 x to the fifth, and then plus a sixth is minus 1/16 a naught x to the sixth plus so on. So there we go. So we have everything we need. Let me magnify it a bit more. So that's where we're at. So now if you just combine like terms and make it a bit simpler, so this becomes y is equal to a naught. So that's gone. And then I'm going to write the other a naught term. So a naught, I'm going to take that. So minus 1/2 a naught x squared. So that's gone. My next a naught is that one. So minus 1/8 a naught x to the fourth. So that one's gone. And then let's see what other a naught I have in that one, which is minus 1/16 a naught x to the sixth. So that's that one, and that's all the terms I have for a naught. Alright, now the rest of the terms is 0 except that one, so you get plus dot 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 plus a1x. So you could then clearly see here that your solution, if I factor out an a naught, I get 1 minus 1/2 x squared, right, minus 1/8 x to the fourth minus 1/16 x to the sixth minus dot 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 close parentheses plus a1x. And you kind of were expecting that anyways, because it's a second order differential equation, right? So if you have a second order differential equation, then you're expecting two solutions with two constants. So you were expecting something like c1 y1 plus c2 y2 as a solution, and you see it here. Because like your c1 is represented with a naught, your y1 is represented by this infinite power series, your c2 is representing your a1 is representing c2, and the second function is just an x. You don't always have to get two power series. Sometimes you just get a closed form or a simple elementary function for either one of them at any given time. So that will be the solution.